Hi everyone, welcome back to Workshop, and today we've got a little bit of a restoration job on. This is an Agilent 3631A power supply. Yes, I did just repair a 3632A power supply. This is one of the variants. This is a 3631A, and as you can see, it looks like it's been dropped from a great height onto the front. It's all mangled and bent and all the rest of it, so we're going to have to replace that. The display board came with it as well. It looks to be intact, a little bit rusty, but I don't see any breaks in the glass or anything like that, so hopefully the VFD is okay. The rest of it does look to be intact. It doesn't look to be bent. The chassis enclosure doesn't look to be bent at all, which is a little bit surprising. And inside we've got the PCBs. It's a different layout completely to the E3631A. You've got the main power board in the bottom there, transformer obviously, and the main processor board is up on the lid, on this hingeable lid here. I have actually cleaned this up. It was so bad inside with dirt you could hardly see the silk screen on the PCBs, so I'll pop up a couple of photographs before I cleaned it, but it was so bad. I basically poured IPA all over the boards, just basically poured it in to soften up all the dirt and grime on both boards. Then I took it outside, and believe it or not, I just took the garden hose and I just hosed it to death and got rid of as much of the grime and dirt as I possibly could. So yeah, so it's definitely a lot cleaner than it was. I never took the boards out, I never took the wiring out or anything like that. I just basically hosed it down, and then I dried it off with a heat gun and left it for a few days, so it should be dry now. So the plan is to replace the front panel. So I managed to pick up a couple of bits and pieces from eBay. I've got a replacement panel with a Legend sticker that can just be stuck on the front there, and also a new Agilent E3631A screen for the front as well, so that should get us back up and running. So the plan of attack is I don't really want to power it up with it in this state. I don't see much point. I think I'll just go ahead and replace the old panel with the new one and fit the display board to it, etc. And then once I get it sort of ready to go, then we'll do some checks and then power it up and see if it works. So to get these banana sockets off, it looks like there's nuts in the back, but I will have to desolder all the wiring first and remove these capacitors as well, and then it should just be straightforward to refit them onto the new panel. So I guess the first thing to do is peel back this adhesive backed sticker and attach it to the new front panel. It looks like it lines up just quite nicely, all the holes, so I think I'll go ahead and do that now. I really want to just have one shot at this, so let's see if I can get it right. There we go. Perfect. So now I'll clean up the banana jacks and ready to fit them next. The banana jacks are not in the perfect state. They look all burred a little bit with the fingers and hands that have been on them over the years with the looks of it, but compared to the new front panel anyway, but I think they'll do. What I'm tightening them up with, actually, I found this on the net somewhere. Somebody had produced some STL files for the 3D printer, and I just 3D printed these all different sizes, and they're just great little nut spinners with little wee handles on them that you can use, and they're all labelled like this is 13mm, 5mm, I think that's a 4, no 5.5, so they're all varying sizes, and they really are useful. Being printed in PLA, they're not metal, so they don't tend to scratch anything, plus they're quite deep for the likes of these bananas where you've got the solder shaft coming through. Some sockets are a bit too short for that and you don't really get good purchase on the nut, but these are really good. Oh, there we go, fitted. So the next thing to do is to reattach the wiring, but it will need a little bit of a clean up. These wires are wound round the posts, so I'll have to straighten them out. I don't know if I've got enough length to cut them back a little bit. Let's take a look here. Maybe very slightly, but no, I don't think I'm going to be able to cut them back, so I'm just going to have to tidy them up the best I can and try and rewrap them round the posts. So now I can refit the capacitors. They're all the same size, 470 microfarad, 50 volt. A little bit of solder on them. But I picked up the two of them, and if you look closely, they've got a couple of capacitors. Probably 0.1 microfarad, something like that. Soldered right deep seated into the rubber base of the capacitor there. These two were across the plus and minus 25 volt outputs, so I'll have to remember to put them on that side there. And this is the negative output and that's the positive side, so the negative side of the capacitor goes to that negative side. And that's it. Bananas on, all soldered up. So the next thing is I'll fit the screen here, brand new screen. It just clips into the front, I believe, and then I can fit the LCD and membrane. That's it. Tough to press in, but got there in the end. Perfect. Now off camera I did go ahead and wash this down with soapy water, this membrane here. It was just absolutely filthy, so it's looking a little better now than it was. So let's get that into place. A little bit of WD-40 just to try and get rid of some of that rust, or to arrest it anyway. It does seem to be pretty corroded. There we go. And there we go. It's the front panel, the new front panel assembled. Right, so the next thing to do is just reposition the power supply so I can get access to the back, and I'll also fit the front panel. So the next thing to check is I'm going to just check the primary on the transformer by just put my meter across the IEC socket at the back, as I normally do. So I've had a good look over the boards for any bulging capacitors, any signs of scorching, anything missing, any connectors not in place, and I just don't see anything. After cleaning it up with the hose, with the garden hose, it's definitely made things a lot more visible, and everything seems to be in place. There's no wires hanging off of the mains IEC connector at the back. The digital board, the processor board, looks to be intact as well. Nothing missing, nothing broken, nothing there at all. So I think we're good to go with a power up and see what happens. Haha. And we've got power and straight to output off, so definitely no problem like it was with my last HP Agilent power supply. This one's definitely not got the same fault. It's looking good. Output on, and let's see what we've got on by way of outputs. So it does look like we've got a fault with this power supply. If I'm on the 6 volt output here, that's output off, so that's output on, 6 volts shown on the display. I then go and set a display limit, let's just put up to 6, set 5 amp as well. Come back to normal mode. I then can't adjust the output, it just stays at 0.121. And the output's sitting at 0.25 volts on the output terminals. A little bit odd. So if I then go over to, let's just say one of the 25 volt outputs, put it in the plus 25 volt mode, set the display limit up. Let's put it right up. Back to normal mode, sitting at 0, I've got 40 volts on the output. And if I rotate the rotary encoder, nothing happens. Now a second ago, oh, look at that. It's jumped down to 3 now. And the minus 25 volt side is exactly the same. I'll try recalibrating it. Maybe it's just needing calibrated. Maybe it's all over the place in terms of corruption or something like that. So I'll try that. So power on with the calibrate button pressed in. Well, that didn't work. Try again. So I've had to rip apart the front panel again. One key on the front panel wasn't working, and that was the button that enables me to go into calibration mode. And having a look at the front panel board here, I think I may have found an issue. I thought maybe it was dirty contacts in here. The rubber is okay, so what you have is like a little graphite plunger sort of thing on the end of the knobs there, and they come in contact with these circle of tracks there and basically short out the two contacts, and then they go down through two vias on the other side of the board, and they look clean enough. I think what I'll do is give it a little bit of a clean up here with my fiberglass pen, and I'll see if I can get rid of some of that little corrosion on there as well. So this time I think I'll take off the membrane and just lay the board down and lay it across. I have actually put my meter across the graphite on the back there, and it is actually conductive, so I don't think there's a problem with this membrane. Right, should be able to put power on. I'll just test the output on and off button, and that's working. Yes, that button's working now, and with it all disassembled. So maybe my cleaning up using the fiberglass pen's done the trick. So I'll try reassembling it again. Right, let's try that again, see if we can get into calibrate mode this time. That's better. Oh, we're secured. Now we've got to put in the code. Hopefully the code is the default 3631, which comes over after the number of the power supply. So we'll try it. 3 6 3 1. Great, that worked. Cal setup 1 is for the 6-volt mode, so we'll do that first. What you have to do is make the display read the same as whatever the multimeter is displaying. No, I'm not sure this is going to work because that's reading minus 0.2. Yeah, there's definitely something wrong with this power supply. I've now moved to the high end and it's not changed the output on the meter. It's still stuck at minus 0.2545 and it should have gone up to 5 or 6 volts, I would presume. So there's definitely a problem there. Okay, I've set the power supply up for some testing. What I've done is I've hooked up 3 flukes onto the 3 outputs of the power supply, and I've gone ahead actually off camera and checked all the supply voltage across both of the boards. There's like plus and minus 16.5 volts, there's plus and minus 15 volts, there's a couple of 5 volt rails, there's a plus and minus 1.2 volt rails, and they're all within spec, they all seem to be intact. And also on the 6 volt rail anyway, the unregulated DC that feeds the main MOSFET that's controlled by the microcontroller and the DAC and op-amp circuit, etc., that controls the actual 6 volt output, that seems to be okay as well. So I believe all the power supplies are intact. So what I've decided to do is, because the rotary encoder seemed to be having some effect on the outputs here, I just think that probably the DAC side of things, the digital to analog conversion, may be okay, but because the display didn't seem to go up at all, it just seems to sit at 0.25 of a volt, no matter what output you're on and no matter what you do with the rotary encoder. I'm thinking that possibly the feedback circuit from each one of the output rails that comes back to the microcontroller via the ADC, the analog to digital converter, I have a funny feeling maybe that's what I should look at first. So we need to go onto the circuit board, find the ADC and measure each one of the returned voltages from the output. There's also the return currents as well for the constant current mode. So I'll just turn on the power supply off camera there, enable the outputs and select the minus 25 volt rail. And as you can see, it's sitting at 0 volts on the output terminals. But if I start to wind up the rotary encoder, it seems to be pretty good. It seems to be pretty accurate. Of course, there's still nothing on the display. The display is still reading 0 volts. But I can go all the way up to 25 volts, which is the maximum, 0 to 25 volts, well 0 to minus 25 volts, and it's perfect. There doesn't seem to be any problem with the DAC side of things anyway on that minus 25 volt rail. And there's me putting it back down to 0 again. In fact, it seems to be calibrated pretty accurate anyway. If I go on to the plus 25 volt rail, wind that one, adjusting the pot, and it goes all over the place. That's me going down, and it went from like 3 volts to 40 volts. There's clearly something wrong there. And if I hit the output off, it does seem to clamp it back. And then the 6 volt rail, just enable it again. and it just seemed to be stuck at minus 0.25 a volt no matter what I do with the rotary encoder. So as far as outputs goes, it's only the minus 25 volt rail that seems to be working. Okay, so here's a diagram for the ADC. Please forgive my markups. It's just I just marked it up just so I could work out what was going on here. So up at the top left hand side here, you've got the connector. This is where all the feedbacks for the various power supply outputs, the voltage, the currents for the plus 25, the minus 25, and the plus 6 volt rails come in, voltage and current. So they come in here into this analog multiplexer IC, which is controlled by probably the microcontroller or the ASIC here, switching the various inputs, and the X here, pin 3, is your output. Down at the left hand side here, you've got a 5 volt precision reference coming in, and there's a couple of op amps to generate a plus 10 volt reference and a minus 10 volt reference, and they come into an analog switch here, which is also controlled probably by the microcontroller or the ASIC. And the reason for that will become apparent in a second. So what you've got here is a multi-slope converter, and what happens is the circuit applies an unknown signal and ramps it up for a set period of time, and then a known reference voltage of the opposite polarity is added, and then the integrator will then ramp back down, and when it reaches 0, then the time it takes is proportional to the unknown voltage that came in. That's the basics of how it works. The reason you've got a plus and a minus 10 reference signal is because the polarity of the inputs is both positive and negative, because you've got a 25 volt positive input and a minus 25 volt one as well. So the integrator has to work in both directions. So if it's the minus 25 volt rail coming in, then the reference that is applied after will be the plus 10 volt one. If it's the positive 25 volt rail that's coming in, it'll be the negative 10 volt one, just so you get the different directions. The output from the integrator is then level shifted and it goes away off to the ASIC, and the analog voltage goes to the microcontroller, and all that's controlled via the control of the analog multiplexer and the analog switch. Okay, I might have found something. I was just about to start probing around the analog multiplexer in the scope, and I noticed that one of these op amps, this one here, absolutely burning. So I put the thermal camera on and it is well over 100 degrees. And I've scoped the supply in it and it's plus or minus 15 volts like it should be. And none of the inputs are way above or way out with what they should be. So let's take a look at the schematic and find out what that is. That's U6. And there's U6, right, where is it? Here. That's the op amp, a precision op amp, an OPA27. The other ones are okay. There are different op amps. This is just a single op amp, the OPA27. And it's absolutely roasting hot. So I think I'll have a look at my stock and see if I've got something that's along those lines. I don't know if I've got an OPA27. I might do. And we'll try changing that out and see what happens. And there you go. I've got thermal camera on it now. And as you can see, there it is there. And if I try and position the cursor on it, hard to do and try and film it at the same time. 105 I think I saw there. There is another slight hot spot over there. I'm not sure what that is at the moment, but certainly this one here, that's right on that op amp there, which is right there. So I'll change it out now. Right, I do happen to have an OP07, which is pin for pin compatible. So I'll change it out with this. In the meantime, I'll probably order a couple of OP27s later on, but I'll change this out now and let's see what happens. There we go. A bit gooey underneath that's for sure. Some black stuff underneath the IC. I don't know if that was old flux or what, but I'll zoom in and have a look there. Wow, yeah. So this has got a gain of 2 because you've got a 10k and a 10k. This has got a gain of -2 because you've got a 10k and a 20k feedback there. So I should be getting plus 10 volts and minus 10 volts on pin 7, and the 5 volt dead coming into them both. Let's take a look at that. So here's the op amp here, U3. We'll go into pin 3, which is the 5 volts coming in. And there it is, 5.0005, spot on. And we'll take a look at pin 1, which should be the non-inverting op amp. There. We're getting 14.5 volts. I wonder if that's going up to the rail. Not quite. Power supply on that op amp's plus 15.3 and minus 15.4. So the supply is okay. So that's not right. Let's take a look at the other op amp. Pin 7 is the output. Minus 14.8. That's not right. So I think we'll check the resistors around about that op amp. There's R7 there. 10.5k. I don't like that. Here's R6 here. 10.8k. Wow. That is miles out. Try it the other way around. And then on the other op amp, the inverting op amp, it's R8 and R9. 10k and 20k. R8. Well, that's 10k. And R9. Oh, this one's not looking good. R9. 20k this should be. 10 mega ohms. Yep. I'm going to change out all 4 of those resistors. Okay, that's the resistors changed out. So let's see what we've got. Here's pin 3 again. That's the 5 volt reference input. 4.5 volts, spot on. And here's pin 1. That's better. 9.99 volts. And pin 7, minus 9.9 volts. Not spot on 10 volts, because I didn't use precision resistors. So once the power supply is up and running, I will change them out, because I think they should be precision resistors, definitely, because on a reference circuit. So there it is, the 4 resistors I changed out, and I had plus 10 volts there and minus 10 volts there. Perfect. Well, I think that about wraps it up for the first video. So a recap, I've rebuilt the front end, I've cleaned out the power supply, cleaned the PCBs, etc. I've found some components on the processor board, some dodgy resistors, changed them out. 2 op amps that were dodgy, replaced them with like for like, and we've still got more or less exactly the same symptoms. So in the next video I think I'll concentrate a bit more again on the ADC and perhaps the DAC as well, the digital to analog converter, and see where we can go from there. Thanks for watching.